Abu Dhabi, the richest city on the planet. It wants to join the City Super League and is undertaking an incredible transformation, building this extraordinary skyscraper, Aldar HQ. Nothing like it has ever been attempted. It'll be a race against the clock. Will this megastructure push even Abu Dhabi to the limit? Abu Dhabi is in the midst of a construction boom. It's the largest of 7 sheikdoms known as the United Arab Emirates. Its capital, also called Abu Dhabi, is the richest city on earth. Its ruler, Sheikh Khalifa, has a cool $875 billion in the bank and an audacious spending strategy to match. He wants to transform the skyline and compete with the international elite of London, New York, and Hong Kong. But this is not the first time the Emirate has stood at the crossroads. Just decades ago, Abu Dhabi was a desert backwater, until the discovery of oil in 1958 brought unimaginable riches to its ruler, Sheikh Zayed. As the petrodollars flowed in, he converted the shell houses into high-rise, and the traditional way of life was swept away. Today, Abu Dhabi is a thriving metropolis, sitting atop the world's 5th largest oil reserve. But black gold alone cannot put this city in the Super League. To do that, Sheikh Khalifa must lure big business and tourist dollars. Abu Dhabi must expand to thrive. To put Abu Dhabi on the world map, fledgling property developers Aldar plan a whole new micro-city, Al Raha Beach. It's an ambitious proposal. At 11 kilometers long and almost a kilometer wide, this city on the sea will be the biggest project ever attempted in Abu Dhabi's history. Mohammed Al Mubarak is in charge of delivering this audacious development.
The vision of their highnesses and the vision of Aldar was to create this almost mini city where people can live, study, play, and work in one destination.
Al Mubarak must attract investors if Al Raha Beach is to succeed. So to launch the project, he commissions a signature skyscraper.
Creating an iconic structure on Al Raha Beach was of vast importance on basically putting Al Raha Beach on the world map.
Al Mubarak sets Lebanese architect Marwan Zayed the task of designing an icon that raises the stakes even higher. The building will become Aldar's headquarters in the heart of their colossal development. But creating something new in a land where the iconic is the everyday won't be easy. Neighboring Emirate Dubai has taken center stage with a number of headline-hitting projects. The world's tallest skyscraper, Burj Khalifa, the Palm, and the World, and the emblematic Burj Al Arab. To stand out from the crowd, Zayed knows he must redefine the extraordinary.
Simple can be powerful sometimes, and especially in architecture. You can see it since the pyramids of Egypt. Most of the iconic buildings are very simple buildings.
But it isn't until Zayed is relaxing on a plane that he has a brainwave.
But I couldn't sleep, so it was a moment of relaxation, you know. And then the idea came simply. So I took a pen and I drew it on a sketchbook.
The design is simple but daring. A round skyscraper taller than the Statue of Liberty, with a curved glass skin covering the area of 4 football fields.
To be honest with you, the moment I imagined it, I knew it was a winning concept. I knew it was something different.
In fact, the design is so unusual, Al-Mubarak initially doesn't know how to react.
And when I first looked at the MZ design, I was a bit confused in the beginning, to be honest with you. I felt like I was looking at a comic. I felt that this was a flying saucer and basically it landed on Al-Rah beach. And I just kept on staring on it for like another 15 minutes. And after 15 minutes, I just fell in love with it.
Zayd's design is inspired by nature. 2 giant circular curved walls of glass mirror an open clamshell.
Architecture is nothing but imitation of nature. At the beginning, the idea was so geometrical, very pure. It's like a seashell.
The seashell has deep meaning for Abu Dhabi with its seafaring heritage. But a circular design poses a problem. Just like a coin that stands on its edge, it risks being unstable. The circle must be balanced. So Zayed turns to some very old school geometry.
The real challenge of the facade, of the circular facade, was to find the 2 points where the building should pose on the ground. And for that, I had to go back to one of the oldest rules in architecture, proportion. When you have a circle, you can divide it into a pentagram. And that pentagram, in fact, is a representation of the cosmic body of the human being. So you can put a man in that pentagram, the man and the universe. So the pentagram will define the 2 points of the circle where the facade will lay on the ground. And this will create the perfect balance.
It was the same thinking that led 16th century philosopher Heinrich Agrippa to draw man as a pentagram inside a circle, and has helped architects to proportion buildings for centuries. But it's not the skyscraper itself that poses the first major challenge. It's the proposed site.
They wanted to show me the site, but all you can see was the sea, nothing but the water.
Unbelievably, the solid ground required for Aldar HQ does not yet exist. The desired location is 700 meters out in the Persian Gulf and 8 meters underwater. New land must be created. Over 3 million cubic meters of sand must be found. Surely a simple task with Abu Dhabi's endless desert dunes. But desert sands are too fine to build with. The land would just slide into the sea. Marine sand is needed. Its larger grains help it stick together, creating the perfect base to build on. Dredging sand from the seabed is one solution, but fortunately, the last Sheikh has already done the job for them. Whilst cutting a shipping channel in the late 1970s, Sheikh Zayed created an island of discarded sand. Luckily for the engineers, it's just across the water, so they decide to move all 20 million cubic meters of it. A fleet of cutter dredgers eat their way into the island. These are no ordinary dredgers. It takes an enormous claw layered with 48 reinforced steel teeth to slice through the hardened sand. The sand is pumped through a floating pipe to the construction site. Here, excavators toil 24 hours a day to flatten the virgin ground. After 8 months, the land for Aldar HQ is fully formed, and with this, the first major problem overcome. Now, engineers must somehow turn Marwan Zayed's radical design into an engineering blueprint.
The building is bellied.
But it soon dawns on the engineering team that time isn't on their side.
We mapped out the program and it was, I realized that basically from this blank sheet of paper we would have to start piling within 2 months, which is absolutely unprecedented for a building, well, for any building, but certainly a building which is of a unique geometry.
Aldar want their skyscraper completed by an astonishing deadline. In just 30 months' time, the eyes of the world will be on Abu Dhabi when it hosts its first Formula One Grand Prix. The racetrack will be on its own designated island, complete with hotels and theme parks. And Aldar are building the lot. The international press and tens of thousands of visitors will descend on the city. It's the ideal opportunity for Aldar to showcase their new HQ. But to stand any chance of meeting this target, the team will have to pull out all the stops. Just 1 month after design has started on Abu Dhabi's round skyscraper, the construction team arrive on site to begin foundation works. For construction manager Miles O'Sullivan, the schedule is a shock.
With the design not complete and being told you're going to pile in 1 month, almost crazy.
But it's not just the first deadline O'Sullivan has to worry about. Aldar HQ's round curved shape presents an enormous sail-like area when wind strikes. Wind tunnel tests must be done to prove the foundations can take the strain. But the results won't be back until work has already started. Abu Dhabi is regularly hit by high-pressure winds that sweep in from the Persian Gulf. But building Aldar HQ so close to the sea will put the foundations under another kind of pressure.
Digging for Aldar HQ is very similar to digging here in the sand. What you get as you dig down is you'll get to see the groundwater starting to surge through the sand. And in fact, it's that groundwater that we see start coming through the sand here that's creating the pressure and obviously creating the issues for us when we do the construction.
The upward pressure of the water and the loose sand pose a problem for foundation construction. Before excavation can begin, the team must build a solid barrier called a diaphragm wall or D-wall. It's a concrete barricade formed of interlocking panels which socket into the bedrock and reach 16 meters below the surface. The D-wall holds back the loose sand and the surging seawater, ensuring the ground inside the barrier can be removed.
These areas here, what are these?
The D-wall must be built before the foundations can be laid. But with the blueprint above ground or work in progress, the team can only hope that over-engineering the foundations will make them strong enough. The design calls for about 400 concrete piles that work in two ways. Half of the piles rely on friction with the ground to secure the structure to the rock and sand below, whilst the remaining piles drive deeper into the rock to dissipate the building's immense loads into the ground. On site, D-wall construction begins. It's the same process ongoing at this Abu Dhabi construction site. Until recently, Al Raha Beach was just a vision for Aldar's Mohammed Al Mubarak, but the dream is slowly emerging from the sea.
Seeing that land come up, seeing the amount of basically work and the amount of basically staff we had on the ground to make sure that was going to be done, that was like watching Rome being built.
The D-wall and concrete piles create a firm foundation upon which to build Aldar HQ. But the force of the sea pushing up through the sand still poses a threat to the skyscraper.
A great way of demonstrating the problems we faced at Aldar HQ with the groundwater is in imagining that this bottle here is Aldar HQ. And as I push the bottle down, you see forces are exerted on my hand. And in fact, that's the groundwater trying to push the building out, trying to push Aldar HQ out of the building site.
To keep the site dry during construction, water is sucked out of the sand and pumped out to sea. But that's only a short-term solution. To protect this skyscraper in the long term, the team need an extra defense. It's a giant slab of concrete called a raft. It creates a barrier against surging water, stops the piles from punching up through the building, and acts like a snowshoe to evenly distribute Aldar HQ's 59,000-ton weight into the ground.
Raft construction for Aldar HQ is 12,000 cubic metres of concrete, which is a 30,000-ton structure. It's a huge element.
With 2,000 truckloads of concrete to pour, it's a job that continues into the night. But engineers are just getting to grips with the severe forces that will affect the piles. The unique shape of the skyscraper will capture wind like the sail of a yacht. There are no guarantees the foundations will be strong enough to cope with the loads.
The advanced construction works had to commence so quickly that we didn't have time to do the wind tunnel test. It was important that we did one, primarily because this is a unique shaped building.
Gibbons calls upon wind engineer Roy Danoon in Colorado, USA. He puts a scale model of the HQ through its paces in his high-tech wind tunnel.
Right at the start, Craig Gibbons actually called me and said, "We've got something really unusual coming up. Can you take a look at it and give us your first best guess of what the wind loads might be? Give us some guidance on how to get to some loads for the foundations, because this is running on such a fast-track schedule."
Knowing that Gibbons is already building the foundations, Danoon wastes no time in firing up the fans. If the tests reveal the wind loads are higher than predicted, the foundations already in the ground may have to be redesigned.
To be putting in the foundations before we could finish the wind tunnel testing, that always gives us a little bit of cause for concern.
Danoon is right to be worried. He knows how high-altitude wind impacts on very tall rectangular skyscrapers. But Aldar HQ's lower height means another type of wind is the threat.
When we look at the really extreme wind speeds in the Middle East and in this region, we find that the highest, what we call gust wind speeds, the short events, are caused by thunderstorms.
Abu Dhabi may appear sun-soaked, but during the spring, the intense sun heats the moist air, causing spectacular thunderstorms. Wind speeds can escalate up to 137 kilometers per hour.
The key issue with thunderstorms in this region is that they give the absolute highest gust wind speeds. Now, for the very, very tall buildings, that's not too critical because they occur down low. For Aldar HQ, they were really critical.
Thunderstorm winds are strongest between 50 and 150 meters above ground. Aldar HQ is right in the danger zone.
In advance of getting the wind tunnel test, we'd speak a lot with the wind tunnel engineer, Roy Danoon. And Roy would wind me up about the kind of loads he was getting, etc. And knowing that the piles were going in as we spoke.
Wind hitting Aldar HQ's sail-shaped facade puts the building's narrow base under pressure. The wind wants to twist the structure. The foundations must be strong enough to resist these forces.
A little bit more smoke there, Doug. And if you could just crank the speed up in the tunnel just a touch. A little bit more.
Danoon analyzes the wind tunnel data. Fortunately for Gibbons, It's Denoon's jokes that have no foundation.
And I got the results back from the wind tunnel test, and they were within an absolute whisker of my early predictions. And I was just delighted by that. I couldn't wait to get on the phone. They were pretty relieved, I think, because I think they'd been sweating on it a bit.
It was a great relief to know that Roy was just winding me up, and that in actual fact the wind loads were very much in line with what our expectations were.
The results of the wind tunnel test are great news, but the relief is short-lived. Now the structure needs a super strong backbone or core. But again, conventional building won't fly with this design.
For Aldar HQ, one core wasn't enough. We needed two cores, in fact, to take all the loads down into the structure.
Aldar HQ needs two concrete cores for extra stability. The twin spines rise a full 125 meters from the concrete slab to level 23. Reinforced with 6,500 tons of steel, these cores will transfer the loads into the piles. But to channel these forces safely, the concrete must be cast without any flaws. They need a way to build the cores as two single pieces of concrete. The answer? To slip form. It's a clever way to build big concrete towers. Liquid concrete is poured into a giant mold, which forms the shape of the structure. The mold slowly climbs up the core as it's cast, forming a single concrete tower without any joins. Seamless concrete will ensure the HQ's cores are strong. But these 125-meter backbones must be built in only 6 months. It's the same process ongoing at this Dubai construction site, led by the Aldar HQ team.
We are calculating how much per hour we need to climb, and then how much concrete we need to place in every hour.
Slip form is fast, but on this schedule it's not fast enough. O'Sullivan has a trick up his sleeve to speed up construction.
We set a challenge to both cores, who could get up there first.
The teams battle to reach each level before the other. The cores grow meter by meter under a constant cycle. The concrete is released and poured around the steel reinforcement. Hydraulics anchored to the structure raise the mold or shutter so that the next layer of concrete can be poured.
Manpower is a key focus because slip forms are very labour intensive. You need to make sure that the guys are on deck, they're there at the right time, they're doing the right works.
4 months into core construction, the two teams are neck and neck in the race to the top. Core 1's team leader keeps a close eye on Core 2's height.
It's been my benchmark, so if I'm doing better, I'll be ahead of them. So a lot of pressures are there. My boss is telling me, do this, go up, go up, go up. But it's good, the pressure is good.
Core 2's leader also feels the strain.
I'm working 24 hours today. I try to finish more earlier than the other core.
Every month, the builders pour enough concrete to fill 1.5 Olympic swimming pools. But the teams aren't home and dry yet.
There's still a challenge to finishing. Cores are renowned for going up quickly and sometimes having problems, so there's a lot of coordination effort that goes in to make sure that they do go up on time. We had structural steel elements to cast in. We had crane connections to get right.
After just 6 months, the two cores are approaching the top. Core 2 is only a meter or so behind, but Core 1 push ahead to victory.
Core 1 won the race. It's really good to know that we're on top.
For O'Sullivan, the contest to build the cores in record time has paid off.
A lot of planning goes into the cores. To see it come off, a fantastic feeling. But it's only a stepping stone, the core construction. There's a lot more to go on.
The team have so far overcome the obstacles to bring Aldar HQ to life. But now they must face their most complex challenge to date. 1 year in, and Abu Dhabi's radical skyscraper is beginning to take shape. But with only 19 months to the deadline, the engineers must crack how to build Aldar HQ's vast external shell. The design demands a heavyweight shell to support its wide girth and survive huge wind loads. But the architect stipulates open office space, floor-to-ceiling windows, and panoramic views of the Persian Gulf. In the United Arab Emirates, the shells of rectangular skyscrapers are built with concrete. But the geometry of Aldar HQ's shell is so complex, it must be built with the precision of a Swiss watch to fit together. On this scale, achieving millimeter accuracy with concrete is practically impossible.
We knew at the outset a wholly concrete building was never going to work in this instance.
And Stuart, I understand that now we've been able to get a high degree of repetition through.
And there we go.
The engineers need another solution. The answer? A specialized steel exoskeleton called a diagrid. It's a muscular but slender steel frame that will form the HQ's unique shape and will channel forces through its high-strength beams and joints into the cores.
Steel is very strong as a single element, but meshing them all together gives us this added strength and also allows us to make these rather unusual shapes.
Very first sketch of the B&U, however, is the impact on the floor structure. So we could have 3 teams of guys working.
The steel exoskeleton should make the architect's vision possible, but it'll be a first for the United Arab Emirates. Constructing a skyscraper like this will be a step into the unknown.
The geometry of the building presented a significant challenge to us, but the other challenge was that a diagrid building, or buildings using this diagrid system, had never been built before in Abu Dhabi and the UAE.
Let's have a look at it if you don't mind.
It'll take expert steel fabricators to pull this job off.
When we first seen the design, it was something that we knew we had to put our most experienced guys on it. The structure's very, very complex.
The army of fabricators work in shifts around the clock to cut and weld 2,500 tons of steel. The factory is building a series of A-shaped steel sections, weighing up to 30 tons each. They will connect together to form the structure's signature curves. But if manufacturing these giant A-frames is not a big enough job, lifting them into position on site will be a major challenge.
Great to see the steel arrive for the main diagrids, the main columns to the structure. Huge sections. The thought of actually starting the steelwork some 18 months after we started the job, fantastic.
But excitement of the first A-frame delivery is soon replaced with trepidation. Lifting these monsters will be a precision job, and tensions run high.
When we rigged the first A-frame up, you've got to put all the chains on it. It would take maybe an hour to rig it up, and everybody's then thinking, I hope this is going to work. Everyone is on tender hooks.
Now is the moment of truth. The A-frame is lifted off the ground.
There was a big ah from the crowd when it went in.
The first exoskeleton section is finally bolted to the base plate.
To see one go in, an amazing feeling. First A-frame up. Again, a milestone achieved, but then a lot more to go.
Another 99 A-frames must be fitted to form Abu Dhabi's unique skyscraper. The handover date is now just 19 months away. So the team must now focus on the HQ's interior. The structure needs an alarming number of restrooms, 85 in total. This is no weekend DIY job. It'd take an army of plumbers and time the schedule cannot spare. So to fast-track the task, the team innovate again. with prefabricated washroom modules or pods. A pod is a factory-made restroom, complete with lavatories, basins and mirrors, ready to plug into the building. The team plan to lift these 12-ton pods by crane and lower them into the cores like a giant game of Tetris. Construction is a finely tuned sequence. The pods have to be in before the exoskeleton blocks access to the cores. Aldar must approve the design fast, but there's a problem.
We produced a lot of visuals and graphics which we had signed off. Then we actually built the pod. We went to look at it at the factory and a lot of people thought that's it.
But Aldar unexpectedly rejects the pod design. It's just too ordinary for such a futuristic skyscraper. It will take months to remodel, and the exoskeleton can't wait. The whole plan could go down the pan. The only option is to leave out 2 roof sections and drop in the pods later, but this has its own dangers. With 0 hour looming, the team must now wrap the building's skeleton with a glass skin. And no one has ever built a glass facade like it. The geometry of Aldar HQ is highly complex. 2 giant bowed facades cover an area the size of 52 basketball courts. A third narrow surface joins the round facades like a zipper, arcing an extreme 290 degrees from one side to the other. But curved glass like this doesn't exist. The engineers need another plan. The secret to covering a curved surface with flat glass is its shape. Square glass isn't an option. Squares can only bend in one direction at a time without distorting. Aldar HQ needs triangles. They can pivot on 3 axes and seamlessly join with their neighbors. To form these complex curves, it'll take 25,000 individual panes. But before glass production can begin, the team must know what wind pressures it will face. It's back to wind engineer Roy Danoon, who must test the design in his wind tunnel.
When we first saw the design, we knew there was some potential for some quite high glass design pressures. If you under-design a pane of glass, then it will be sucked out the building.
The large facades are most likely to cause trouble.
The biggest loads on the overall building are the winds coming flat into the wide face, so it's capturing it almost like a sail. The wind comes into the centre and spreads out around the building, and where it separates and splits away from the building around the edges, that's where we see the largest pressures.
The pressure is like a big SUV hanging off the outside of each panel. But that's not all Danoon's test reveals. The circular shape of Aldar HQ creates another problem.
When we initially saw the design, the sharp edges threw up this at the warning flag that said, look, we can get some pretty large pressures here.
Where the wind hits the edge of the narrow strip of glass, it spirals in on itself, creating a vortex.
You see this recirculation of the flow. It separates away, and you get this little bubble on the surface where the wind isn't hitting, and then it comes back in to meet the surface again. That's typically an indication that that's where your highest design loads are occurring for your glass. And that's very, very strong suction force is what that little bubble means.
To stop wind sucking glass out of the HQ, each pane must be beefed up with thicker glass and a stronger frame. But that does nothing to limit the scale of the job ahead: installation.
You talk about 25,000 pieces of glass to do that for the building in 10 months. It's a monumental effort. It's a constant battle, making sure that you get the glass to site.
But having the glass factory on site is a lifesaver.
It made it easier for the site to actually call up on glass. Once they are installing the panel, they ran out of glass, we're immediately on the phone, hey, we need more panels over there. So we got them on a truck, and 5–10 minutes later they were on the site.
The glass factory sends the panels to the site by truck, and the panels are lifted by crane up to the installation team.
The constant pressure was the program.
The glass is pulled onto the floor plate, but it takes a team of 8 specialist riggers to install the panels.
Probably the hardest thing was the sheer volume that had to be installed.
Fixing glass on a curve at this height means the panels have to be swung out from a platform that hangs out of the building. It should be easy, but then this team have Abu Dhabi's wind to contend with.
The wind here can just blow in from nowhere. It caused us no end of problems. The glass would start to revolve and spin. We would get a choice whether to lift it, bring it into the building, put it down, or to put it straight back down on the ground. They were decisions that had to be made on the spot. And you don't want a large panel coming down from 20 stories. Just contemplating that, it doesn't bear thinking about.
This glass panel makes it into position in one piece. But the team have another 29 to install every day if they're to meet their targets.
We got it up to 30, 32 on average, and I think the best day was over 40.
But as the line of glass fast approaches the top, the team must install the delayed washroom pods to close up the roof steel.
Yeah, so if they did... You could do 15 metres. 15 metres in one day. So you're 120 metres.
The new design is finally approved, and after 10 months, the 12-ton modules start to turn up on site.
The pod drops are quite quick. We hook them up, we take them up the 140 metres to the top of the tower crane.
The pod can now be lowered into the core shaft. It's a tight fit with just 75 millimeters of clearance.
When I saw the first pods in, it was a relief that that saga was over and we'd actually managed to achieve what the client wants.
The pods are on the move, but the long delay has serious consequences. Finishing the exoskeleton should be a straightforward task, but the incomplete steel roof has sagged out of shape. Eight months from the deadline, and the world's first spherical skyscraper is fast approaching completion. But with the end in sight, construction hits a serious snag. The delay in fitting the washrooms into the cores has forced the team to leave the roof arch open, causing the steel to slouch out of shape. The arch of the HQ's lightweight roof is the key to its strength. Its curves evenly distribute the forces down into the foundations. But if any elements of the arch are missing, the forces cannot flow away. The roof will sag under the weight. To discover how serious the slump is, the steel is surveyed.
I've made a phone call to our site supervisor, Bob, and asked the question of what the actual sag was recorded, expecting it to be around about 50, 60 mil. When we got the figures of 150 millimetres, I was a little bit shocked.
With a building that relies on precision engineering, a 150mm sag is a huge problem. The roof will not slot together. The brackets to connect the remaining 40 glass panels will be out of alignment. There is no time to redesign. The team have to somehow make the roof steel fit together. The only way is to lift the entire roof into position, and it weighs a staggering 200 tons. Even for experienced steel engineer Bob McPhee, this is a serious undertaking.
I hate it when you start waking up thinking about your work. I've never liked to do that.
To lift the roof arch, 2 hydraulic jacks are positioned on top of a load-bearing wall, carrying 80 tons of weight into the core. 2 more jacks are propped with 16-meter-tall steel columns and channel 40 tons each into the concrete floor of level 23. The props are packed with steel slabs to hold the roof in position as the jacks are raised.
The roof was moving firstly a couple of millimeters, then 5, then 10, then gradually into its position 20, 50, 100, and then into its final position 150 millimeters.
The entire roof is raised by a whopping 170 millimeters. The slumped arch is finally in the right position. All that remains is to lift the last steel section. It's a tight fit. With a millimeter to spare, the roof is finally complete. With just weeks to spare before Abu Dhabi's first Formula One motor racing spectacle hits town, all of Aldar HQ's 25,000 glass triangles are in position, except one. The glass installation team lower the pane inch by inch. No one wants to be responsible for shattering the last sheet of glass. It's a defining moment for the team. Finally, the last pane slots into place.
Ecstatic. Actually see the last bit of glass go in. Amazing feeling. Hopefully the guys here feel the same way, and I'm just overjoyed.
Against all the odds, and in just 30 months, the team have fulfilled their brief. An engineering triumph. This is Aldar HQ. This spherical skyscraper, a world first, rises 125 meters above the Abu Dhabi sands. All 3,000 glass panels mirror the surrounding landscape, reflecting the blue skies and the rolling sea of the Persian Gulf.
Amazing structure. You don't see any circles in the world being constructed, so to be part of that was fantastic.
Mindful of all the issues and challenges and highs and lows in between adds to that feeling of triumph.
Mohammed Al-Mubarak fell in love with an extraordinary idea. But will the building match his high expectations?
It's really a work of art. It's a stunning building. To me, it feels like it should be in a museum. The space is unbelievable. It's really a colossal building. When you come up front to it, it's even bigger than you even imagined. And for it to come from paper to that, it's great.
Already an icon on the Abu Dhabi skyline, Aldar HQ should lay solid foundations for the future of Al Raha Beach. Architect Marwan Zayed is delighted to see his concept sketch come to life.
The building is more beautiful than the original idea because it's real now. It's no longer a simple concept. It's became reality.
Aldar HQ is a structure that rivals not just Dubai's iconic buildings, but can stand proud on the international stage.
The HQ building has really put Abu Dhabi on the world map. If you ask me today, we're not yet into the world of Singapore or New York or Paris or London. Will we get there? I absolutely believe so we will.